Probability less than 1, focus on data and how to interpret it when given in different representations. Alright, so what is data? Okay, data is what is observed and documented. Through an experiment. It is critical to have when finding one particular type of probability, but we'll talk about that particular type later on. Again, you can represent data in 3 different ways, the most popular being charts, tables, or graphs. And just going to do a brief refresher on how to read graphs, do a couple of questions, how to read tables, do a couple of questions, and then how to look at graphs and do a couple of questions. Okay. So assuming the pie charts are representation from grades in this class, find the probability of the following. So a student gets to go to Flex, and then a student's grade is between a 60 to 69. What makes some probability questions hard is you have to know just a little bit about things that aren't given to you. So, for example, you know you get to go to Flex if you have a B. Okay? So, Flex is B or an A. Okay. So again, probability is desired outcome over total possibilities. Desired outcome gets to go to Flex, so the student has a B or an A. Divided by total possibilities is total students. Okay. So how many students have a B or an A? C represents this portion. D is represented by this portion, so we don't want that. 4 kids, or 14.3%, have an A. So you can choose either just use the number of kids or the percentages. I'm going to do the number of kids. 4 kids have an A. And then 12 kids, or 12 students, have a B. Okay, so 4 A's and 12 B's. And total possibilities. Again, 4 kids with A's, 12 with B's, 10 with C's, and 2 with D's. Okay, so 4 plus 12 is 16, plus 10 is 26, plus 2 is 28. Again, if you have an A or B, I want that, so 4 plus 12, we're going to add these. It'll be 16 out of 28, and again, you could simplify that if you want to, or you can change it to a percentage. Again, I'm not going to waste my time or yours by doing that because, again, you're in math too because you know how to do it. So what I want y'all to find is a student's grade is between a 60 to 69. First, starting out with what is the number of desired outcomes. Okay, so 60 to 69, you have to know a little something about the grading scale. Well, A is a 90 to 100, B 80 to 89, C is 70 to 79, and a D is 60 to 69. Okay, so desired outcomes between 60 to 69. I want this portion, or 2 kids. Okay, second thing, what are total possibilities, or what's the total number of kids in the class? We just found that, right? It's 28. So the probability that the student's grade is between a 60 to 69 is 2 over 28, or 1 over 14, or again, you can change it to a percentage or some decimal. But again, if you get to 228, you could eventually get to your answer. Alright, so interpreting tables, reading tables. Over here on the far left, your number of pets, this is how many they have. Okay, so number of pets. Tallies is saying, okay, if one tally is here, that means one person has 0 pet. So you kind of read these tables right to left. What I mean by that, 4 people have 0 pets, right? So the number of people, or how many people have this many pets. So 4 people have 0 pets, 6 people have 1 pet, 5 people have 2 pets, 3 people have 3 pets, 2 people have 4 pets. Okay. So find the probability of the following. The probability that you have 0 pets. Again, so how many people have 0 pets? 4. Now, how many total people are there? To find the total, you just add up all of these. Okay, you can add up all of those. 6 and 4 is 10, 5 is 15, plus 3 is 18, plus 2 is 20. So total people is 20. Again, desired outcome, probability 4 pets out of total people, or 0 pets, 4 out of 20. Okay. Probability that you have less than 3 pets, or the probability of people have less than 3 pets. What this means is the 0, or you want to find anything that fits this inequality, is a desired outcome. Okay. So simple yes, no answers. Would 0 pets be less than 3 pets? Yes, it would. Would 1 pet be less than 3 pets? Yes, it would. Would 2 pets be less than 3 pets? Yes, it would. Would 3 pets be less than 3 pets? No. Would 4 pets be less than 4 pets? Would 4 pets be less than 3 pets? No. Therefore, my desired outcomes are 0, 1, or 2 pets. And total possibilities, again, we just found was 20. So we add up the number of people that have 0, 1, or 2. So 0 is 4, plus 1 pet was 6, plus 2 pets was 5, 6 plus 4 is 10, plus 5 is 15. So again, probability, desired outcome, divided by total possibility, 15 out of 20. Alright, last but not least, we look at graphs. The top of the bar is essentially the frequency, okay? And so if you want to think of the height is your frequency, or how many, and then side to side, or your rows, or your different categories. Okay, so probability of drama. So I want drama. Well, how many people are in this drama bar? So I go to the top and I go to the left, and it's between 0 and 2, so it'll be 1. And now how many total people? Well, this is 4 people in comedy, 5 people in action, 6 people in romance, 1 in drama, and how many in sci-fi? It becomes 4. And so my total, I just add all of these up, and it becomes 9. 4 plus 5 is 9, plus 6 is 15, plus 1 is 16, plus 4 is 20. So probability, desired outcome, divided by total. So again, desired outcome was drama, total people, again, 1 out of 20. Alright. So again, this time for y'all, find the probability of action or sci-fi. Okay. So action or sci-fi. If you're action, you're what I want. So comedy, don't want it. Action, I want it. Romance, no. Drama, no. Sci-fi, yes. I add the total of my 2 check marks. So 5 plus 4 was 9. And then my total people in the group that was surveyed were 20. So my answer becomes 9 out of 20.